Take a sealed drink from the refrigerator on a humid summer day. Within minutes, tiny droplets appear on the outside. They merge, run down the bottle, and leave a wet ring on the table. The liquid is not leaking through glass, metal, or intact plastic. The water comes from the surrounding air. Air contains water vapor, individual water molecules mixed among nitrogen, oxygen, and other gases. At any temperature, there is a limit to how much water vapor can remain in equilibrium before liquid water begins to form. Warmer air can generally support a higher water vapor pressure than colder air. The cold bottle cools the thin layer of air touching its surface. As that air cools, it may reach the dew point. The dew point is the temperature at which the existing amount of water vapor becomes sufficient for saturation. Cool the air below that point, and some water vapor changes phase from gas to liquid. The resulting droplets collect on microscopic scratches, dust particles, and other nucleation sites on the bottle. This is why humidity matters. On a dry day, the dew point may be far below the bottle's surface temperature, so little condensation appears. On a muggy day, the dew point is high. A refrigerator cold bottle easily cools nearby air below it, and droplets form quickly. The bottle does not need to be porous, and the drink does not need to contain water that can escape. A simple test can identify the source. Place an empty, tightly sealed metal can in a room and fill it with ice water. The outside still becomes wet. Wipe it dry, and droplets return. Because the container is sealed and the liquid level does not explain the external water, the moisture must be condensing from the air. The same mechanism fogs eyeglasses in winter. Cold lenses enter a warm, humid room and cool the air beside them below its dew point. Instead of large drops, many tiny droplets scatter light, producing a milky film. Bathroom mirrors fog for the same reason when warm, moist air meets a cooler surface. If the bottle surface is below 0 degrees Celsius, the story can continue. Water vapor may first condense and then freeze, or under some conditions deposit as ice. A visible layer of frost forms because the surface removes enough thermal energy to keep the water solid. The exact path depends on temperature, humidity, and the availability of nucleation sites. The key is to follow the energy. Heat flows from the warmer air toward the colder bottle. The nearby air cools. Once it crosses the dew point, it can no longer maintain all of its water in vapor form, so the excess becomes liquid on the surface. Those summer droplets are therefore not evidence of a leaking bottle. They are a small weather system. The bottle acts like a cold night surface. The air supplies invisible vapor, and crossing the dew point turns that vapor into visible water.